Today's lesson is on volume of cones, and so we're going to be talking about how is the volume of a cone related to the volume of a cylinder. Volume of cylinders, which we did last year. So on example 1, they are filling a cone-shaped pastry bag with frosting from a cylinder-shaped container. How much frosting can the pastry bag hold? So coincidentally, the heights of both of these are the same and their diameters are the same. So what they did here, they showed a cylinder, they showed the cone. Obviously the cone is smaller than the cylinder, and it ends up that the volume of the cone is exactly 1/3 the volume of the cylinder. So we're going to do kind of like we did with the pyramids. It's 1/3 times the area of the base times the height, and you actually have this on your reference sheet. Our base is a circle. Area of a circle, you may remember, is pi r squared. So that's where they got the formula 1/3 pi r squared h. So this one, we don't have that capital B for the area of the base like we did. They could have done that, but they were nice and specifically said this is exactly what it is for a volume of a right circular cone. So we look at the try it. They want us to find the volume of this cone, and we're going to use 3 1400ths for pi. So our formula we just mentioned is 1/3 pi r squared h. So 1/3 times, we're using 3.14 for pi. Our radius is 1.5, 1 5/10. So we'll have a 1.5 squared and then times the height, which is 4. So if we were working this out, order of operations would say we would need to square the 1.5 first. So 1.5 times 1.5. Okay, good. 2 2500ths. And then we can work the rest of that out. Technically, you could have just typed all that at once in your calculator if you want. And okay, so 9 4200ths cubic inches. And again, it's cubic units because it's like how many cubes can we fit inside of this thing. That's our volume. And again, we could write that over in this other box as well. That's our answer there for our volume. You look at example 2. Midori has a cone full of bird seed to feed the birds at the park. What is the volume of the bird seed in the cone? So this one, we talked about it the other day, I believe. They are giving us the slant height of the cylinder, or of the cone, not the height of the cone. So we have to use our Pythagorean theorem idea like we did the other day. Make that right triangle there. You can see the 25 would be like our hypotenuse, and if you work that out, again, they're not showing all the steps here. We square those. We subtract 49 to get 576, and then they did square root of 576. Technically put plus or minus, even though we can't have a negative height. So it's going to be 24 centimeters would be the height. And then once we know the height, then we can find our volume. So volume, we just substitute a 24 in place of our height, and we work that out, and we get about 1,232 cubic centimeters. Example 3, they're giving us something different. Once again, they are telling us the circumference of the base. Well, circumference, that's not what we need. We need the radius of the base. So to get the radius of the base, we can use our circumference formula. Circumference formula, that's not on your reference sheet, so this would be something, if I give you a problem like this, you could ask me for the formula. I'm not going to make you memorize that circumference formula, okay? Anyway, circumference was 6 pi. Circumference, one of our formulas for circumference is 2 pi r. So what they did there, the r was being multiplied, radius was being multiplied by 2 pi. They divided by 2 pi on both sides. Okay, again, they're not necessarily showing this what we would show it normally. Divide by 2 pi on both sides, and then 6 pi divided by 2 pi would be 3. So that tells us the radius is 3 inches. And now we can substitute that in our formula and get the volume is 39 pi. Now this 39 pi, if we read the directions, which I didn't do the first time here, it says what is the volume in terms of pi. So we did this last year. In terms of pi means we keep the pi in our answer. Okay? That's called in terms of pi. So rather than putting in 3 1400ths or something for that, we'll just leave it 39 pi. So let's look at the try it part B. So similar idea here. They want us to express the volume in terms of pi. Once again, they have given us the circumference. So with the circumference, we can use that formula. Circumference is 2 pi r. And we'll just substitute in. They told us the circumference is 16 pi. So then 16 pi is equal to 2 pi r. We're trying to get the r by itself. How will we do that? Divide. They're multiplying, we divide. Always the opposite operation. And when we divide that, 16 divided by 2 is 8. The pi's will just cancel each other out. So that means our radius is 8 feet. So we're not done yet, but we're getting closer. So now we're finding the volume of this cone. It said to put it in terms of pi, so I'm just going to leave the pi there. My radius is 8, we just found, and the height is 21. Okay? If you wanted to here, this stuff's all going to get multiplied together. 8 squared means 8 times 8 is 64. Okay? Then it's up to you how you want to do this. You could do that on your calculator. It's all being multiplied, so commutative property says we can do this in whatever order we want to. So 1/3 of 21 would be 7, and then times 64. Good. So 448 pi cubic feet would be our volume in terms of pi then. And again, once you guys get to the step, really once you get to the step right here with a calculator, you can technically type that all in and get straight to that answer. Just don't forget your pi. Okay, we're saving our pi for dessert here. Don't forget about it. So key concept just recaps. Once again, you have the exact formula for the volume of a cone on your I-STEP reference sheet. So we don't even have to start off with this 1/3 BH like they did in the book here. Let's look at the do you know how number 5. They want us to find the volume of the cone. Estimate using 3 1400ths for pi around to the nearest tenth. So this is a little different look here again that the book's giving us. If we think of our formula, now we're finding the volume of the cone. I'm going to write my formula down and then think about what I know and what I don't know, because this doesn't look quite right to me. So if we're substituting in, they said that we're going to use 3 1400ths for pi. And here we are. Oh, there's the problem. We don't know the radius, do we? Okay. How can we find the radius? Pythagorean theorem. Good. We're going to create this right triangle here. Okay. So the hypotenuse would be 41. Good. It's across from the right angle. It's the longest side here. The R, our radius, doesn't matter. We can call it A or B. If you want to leave it A or B instead of changing it to an R like I did, that's okay. Okay, so 41 squared, 1681. Is that right?
16, that's 40.
Okay, 40 squared, 1600. 41 squared is 1681. Okay, so our next step would be to subtract. Good. So r squared is 81, then we would square root. Square root of 81 is 9. We know it can't be negative. So 9 millimeters is our radius. And now I think we got it about figured out here. We'll put the 9 in our formula. Make sure you square it. And the height is which one?
41.
Height's the 40. Has to go straight up and down for it to be the height. 41 they call the slant height because it's slanted, I guess. Okay, and it says we're going to go to the nearest tenth here, so probably rounding. Good. So 3,391 and 2/10 cubic millimeters would be our volume. So what we're going to do is page 435. The easy way of putting this is that we're going to skip numbers 9, 13, and 16. We're going to do 7, 8, 10 through 12, 14, 15, and 17 through 19. But like I said, if you want to just look at it, these are the 3 we're going to be skipping. Might be easier to look at it that way. So this gives you an idea how to find the volume of cones.